Let's learn IIP. Today, we will create an IIP application that processes large XML files using File Input Node and Java Compute Node. What are the problems that you would face when handling large files in IIP? 1. High memory use. 2. Large latency. That's large delay to process a file. So what can be done about this? When you have a big task to accomplish, you break it into smaller ones and distribute among your peers. Let's do the same with big files. Break the big XML file into smaller sections and use additional instances, also known as threads, to do parallel processing. When you slice an XML file, you have to make sure that the smaller output XML that you generate is also a valid XML structure. You should not be doing a simple string slicing. Now we acquire the XML file using File Input Node, whose property is set to read the whole file in one go. The other options that you have with File Input Node are that you can read one line at a time. You don't have to read the whole file in a single go. Since we're working with XML files, you will read the whole file instead of one line at a time. Polling interval on File Input Node is set to 5 seconds. So every 5 seconds, it checks the folder if there are any new files. For your system architecture, try to avoid polling wherever you can. Instead, go for a trigger-based mechanism such as MQ or a web service. Database polling, email polling, file polling should be avoided when possible. There are two kinds of errors that we cater to in this project. 1. Malformed XML. If the input XML given to us is not valid, then it's considered as a malformed XML and we store that file in the out folder with the file name as malformed. The second error category is application errors. Let's say the Java code that we have written has some programming defect. This will cause an exception list to be thrown, and those errors we will capture into the out folder as well, the proper name. File name indicates the error category here. Message domain is set to XML and SC on File Input Node. With this setting, we will be working with fast XML data structures where parent and child nodes can be traversed easily using XPath. Observe the Java code shown to understand how we access message tree structure. We don't want to be working with string manipulation. Our goal is to accept one input XML file and convert that into multiple smaller output XML files. Screen shows that we use the repeating element in input XML to slice it. That is, we apply a for each condition on the repeating element. With each slice, we also denote the slice number. Here it is shown as 4, the output file which was generated. Output file name on File Output Node has an asterisk in it, a star mark. We are creating multiple output files, as you know. A star symbol or asterisk is used as a placeholder to be replaced by the XML file number. See Java code where wildcard in local environment is set with an integer value. Once all the slices of XML are propagated, then we create an end of the batch indicator called out_statement.xml to indicate that we have completed processing and to show some metadata information. We use this file. What did we learn today? We learned how to acquire an XML file in IIB using file input node. We learned what are the issues with large file processing. We learned how to slice a large XML file using Java Compute Node. We learned how to create files in IIB using file output node. How to set their names dynamically. Then, what's the error handling for malformed XML and generic failure? These are the concepts that we've learned today. If you found the video to be useful, subscribe to my channel and share your feedback in the comment section. Code is available in GitHub and some documentation is available in the blog post. Links in description. See you in the next video.